Hello again. Now we're going to take a look at our lesson for the first section of Chapter 5. First, I have up here our workshop expectations for solving systems of equations. This is Chapter 5, but we won't be doing all of Chapter 5. We're going to be doing some specific parts of Chapter 5. That's why this just says solving systems of equations. We're going to have, looks like 5 I can statements we're going to work on. I can solve a system of equation in 2 variables by using a table. I can solve a system of equations in 2 variables by graphing. I can solve a system of equations in 2 variables algebraically. I can solve systems of equations with no solutions and infinitely many solutions. And I can solve real-world and mathematical problems leading to 2 linear equations in 2 variables, so story problems. So today we're going to focus on what is a system of linear equations and how can we solve that using a table and how can we solve that graphically. Okay, so I am going, if the guest teacher has not passed it out already, please remind your guest teacher to pass out. You're going to have a goldish color packet that we're going to use for notes today. That's what you need to have to take your notes in. If you want to write some additional things down in your notebook, that's a good idea as well. And we are actually going to kind of jump around a little bit in the packet. So as you watch this video, you should be filling out the packet. Let me share my iPad with you. I do not know why my iPad doesn't like to recognize my computer today. Let me do just a couple things here. Let's see if this works. Try this one more time. Did this earlier when I was making the video. Did the exact same thing. Okay, so here is our packet. Solving systems by graphing. We're actually going to do graphing and a table. So first we're just going to talk about what a system is. A system is 2 or more equations, a set of 2 or more equations. We're going to specifically be looking at 2 variable equations, and in what we're going to be doing here, they're all linear equations, but you certainly could solve different types of equations, have a system with different types of equations. So a system of equations is a set of 2 or more equations. And we're not even going to talk about what the solution of a system is yet. What I want you to do now, I want you to turn 2 pages to this. Okay? So we're going to actually solve a system before we talk about what the solution is. But we're going to do that. All we're going to do is we're going to graph. Okay? That's why we did the little review on graph. So our system is marked here with that little brace there. That shows you that those 2 equations go together. So that's our system. I can't remember. I don't believe your book uses that notation. One of our books does and the other doesn't. So if it doesn't use that notation, just know that that's what it means. So we are going to graph both of these lines. We should be experts at this. We practiced. So we're going to start at 5. So I'm going to go up to 5. 1, 2, 3, 4, 5. And then my slope is 3. So I'm going to go up 3 over 1. Or I could go down 3, left 1. I need to use a straight edge. I'm going to give this a shot. It's crucial that you use a straight edge on systems. Okay, we'll talk about that in a second. But you have to use a straight edge. Now, mine doesn't work very well because the iPad issue, but I'm going to try. Oh, that looks like I did fairly well. Okay, now I'm going to graph the other equation. Y equals negative 2x plus 10. I'm going to switch colors just so it makes it a little bit easier to see them, both equations, but I'm going to graph it on the same coordinate plane. So I'm going to go up to 10. All the way to the top. Then I'm going to go down to right 1, down to right 1, down to right 1, down to right 1. I'm going to use my straight edge. Now, if I look at those two lines, if I just use some common sense, if I'm thinking about what is the solution of the system that I graphed here with these two lines, what makes sense? What would that solution be? It makes sense that it is this point here where the two lines intersect. That is the point where both equations are true. Okay, the point where both equations are true, that is going to be our solution. And we can find the point where both equations are true by finding the intersection point. So our solution is going to be that point. So it has to be a point, it has to be an ordered pair where both of those are true, which will be 1, 8. Now, when we solve systems by graphing, we really do need to check because there's a lot of human error involved in graphing. So all we have to do to check is we have to substitute in our 1, 8 into both equations and see if it's true. So 3 times 1 plus 5, that equals 8. So that checks. Then I'm going to plug it into the other one. Negative 2 times 1 plus 10 is 8, so that checks. So 1, 8 is in fact our solution to our system. Okay, so let's go back to that first page and let's talk about what is the solution of a system. Okay, the solution of a system is the point that makes both equations true. Okay, we also call that the intersection point. Okay, so it's the point of intersection. So there are lots of methods for solving systems. We're going to basically look at 3. Okay, we are going to look at graphing, and that's what we're going to look at today. Using a table, but honestly, we don't really ever use that one. But it's kind of nice to, it helps us to understand what we're actually doing. And we're going to use algebra. That's what your book calls it, algebra, but most of the world calls it substitution. So we'll expose both of those there. Okay, so let's go ahead and jump back forward to the graphing since that's what we were just practicing. And let's look at this next one. And if you like using the two colors, go ahead and use two colors when you graph these. So y equals 2x minus 4. Okay, that one's fairly simple. It's already in slope-intercept form, so here we go. 1, 2, 3, 4. Up 2 over 1, up 2 right 1, up 2 right 1. Let's connect those points. Okay, now I'm going to graph the other line. I like to use slope-intercept form. That's my preferred method. And this one is not in slope-intercept form, so I'm going to go ahead and subtract 3x on both sides. And I get y equals negative 3x plus 1. So now I'm going to use that to graph that. So I'm going to go up to 1, and then I'm going to go down 3, right 1. Well, that's nice. Down 3, right 1. So it will happen sometimes when you can't tell exactly where they cross. That's why graphing, we're going to discover, is probably not the best method to use most of the time. But right now, when we're first learning, they're going to pretty much make them pretty obvious as to where they cross. So these appear to intersect right there at 1, negative 2. So we need to check it because there's a lot of human error involved here. So we're going to do 2 times 1 minus 4. That is negative 2, so that checks. And then we're going to do 3 times 1 plus negative 2. That's 1, so that checks. Okay, now at this point, I would suggest you pause the video and attempt these two on your own, and then come back and see how you did. So since you paused the video, now you're coming back to check, I'm just going to take a moment to put these in, to go ahead and graph them, and you can watch and see if you have a mistake and see how you did. So it's a nice one again, intersects at a nice point. So I have a solution of negative 1, 7. So let me check that. 2 times negative 1 plus, that's not what I wrote, 2 times negative 1 plus 9 is 7, and 6 minus negative 1 is 7. So they both check. Remember, the solution is the point, so you've got to write that point. There's my point. If you really look at it, it's a little bit off. That's why we check, because our pencil lead can mess things up. We can just get off on our straight edge. So it appears that my solution is negative 5, 1. But I need to check that. So -3 times -5 plus 5 times 1. So that would be 15 plus 5, that is 20, so that checks. -5 plus 1 is -4, so that checks. So there is our solution. Okay, so you're going to be practicing some of those for your homework and your lesson today. That's what you're going to do for your must-dos. But let's just talk a little bit about the tables. Before we do that, we've already discussed this because we've been checking, but sometimes you're just going to be given a system and then they'll ask you if the ordered pair is a solution. All you do is plug in, just like we did when we checked. So I'm going to do 4 minus 1, that's 3. So that one checks. Then I'm going to plug it into the bottom one. 2 times 4 minus 3 times 1 is 8 minus 3, which is 5, which is what I wanted. So that one checks. So our answer is yes. Okay, now let's take a look at the table. So yours is on the back side, but I put mine a little out of order. They call this method 1, but this isn't a method that we probably will use very often. But we remember when we first learned how to graph, we looked at using a table. Okay, so what we're going to do here is we're going to plug in values for x and then try to see where they are the same, because that's what we want. We want to know where they are the same. The problem is how do you know what values to plug in for x? So I'm just going to start with 0. Okay, so I'm going to plug in 0. I like this pink. I think it shows up. So I'm going to plug in 0 for x. And for y, on the top equation, I would get -3. And on the bottom equation, I would get 3, right? So that doesn't work. They're not the same. So we need to try again. Should we try 1? Let's try 1. 1, we get -2. And then we get 1. Looks like we're getting closer. Let's try 2. 2 is -1. And then in the bottom one, 2 times -2 is -4. -4 plus 3 is -1. So they match. So what does that mean our answer is? Our answer is an ordered pair, right? So the x value is 2 and the y value is -1, because that's what we got for both of those. We get the same answer. So our solution is going to be 2, -1. Okay? So we've got 2 more examples here. Let's just do one. Let's just do A. So our first one's going to be y equals x plus 6, and then y equals 4x minus 3. So let's think a little bit. We're going to be adding 6, then we're going to be multiplying by 4, and then subtracting 3. Okay, so just sort of think about where we're going to start. So let's go ahead and just start with 0. So we get 6, and we get -3. Okay, not terribly far off, but let's keep going. Let's see. If we do 1, we get 7. And we get 1. Okay, maybe getting a little bit closer together. Let's try 2, 8, and 5. 3, 9, and 9. So there it is. So our x is 3 and our y is 9. Okay, you are going to work on 2 of your must-do assignments now. Let me go back to our expectation sheet. You're going to do this self-correcting practice, which is a digital assignment. The link is right here. And then you're going to do this catching UFOs, which is a worksheet, which is available for you in class today. So you need to work on both of those things. You also have a Big Ideas 5.1. If you complete your must-dos, these 2, then you should work on your Big Ideas. Please remember to be respectful, be kind, and be on task. Thank you.